The night sky has always been a place of quiet wonder for humanity. To the naked eye, it seems calm and predictable. The planets follow their regular orbits, the stars remain fixed in familiar constellations, and occasionally a meteor blazes briefly before vanishing into the darkness. But every so often, something arrives that shatters that sense of order. Something that doesn't belong on our charts. In July 2025, astronomers spotted exactly that. While scanning the heavens as part of the ATLAS survey in Chile, they noticed a faint speck that didn't match anything in their catalog. That speck would soon be given a name, 3I/ATLAS. At first glance, it might have seemed like just another small object passing through the solar system, maybe a distant asteroid or a new comet. But the initial orbital calculations told a different story. This was not an object from the asteroid belt, the Kuiper belt, or even the far-off Oort cloud. It was coming from far beyond the Sun's gravitational reach. 3I/ATLAS, as the I in its designation suggests, is only the third confirmed interstellar object ever detected by humanity. The two that came before it, Oumuamua in 2017 and 2I Borisov in 2019, had already stunned scientists. But this one might be the most intriguing of all. And with each new piece of data, it becomes harder to simply write it off as just another comet. To understand why 3I/ATLAS is so fascinating, we need to look back at the discoveries that came before it. In 2017, the Pan-STARRS telescope in Hawaii spotted an elongated tumbling object that was later named Oumuamua. It didn't have the visible gas and dust tail of a comet. It showed no obvious signs of outgassing at all, yet its trajectory changed in subtle ways, as if pushed by something other than gravity. That behavior sparked fierce debate. Was it a natural body, shaped by unusual processes? Or, as Harvard astrophysicist Avi Loeb controversially suggested, could it be artificial, perhaps the relic of alien technology? 2 years later, in 2019, came 2I/Borisov. This one looked much more like a typical comet. It had a coma, a tail, and clear outgassing activity. But even Borisov was chemically distinct from anything in our own solar system, suggesting it had formed around another star under very different conditions. After that, the skies went quiet, until July 1st, 2025, when 3I/ATLAS suddenly appeared. This time, we didn't see it creeping in from the outer reaches. It was already inside Jupiter's orbit before anyone knew it existed. The ATLAS system, short for Asteroid Terrestrial Impact Last Alert System, is designed to find objects that could pose a threat to Earth. Its wide-field telescopes scan huge sections of the sky every night, looking for anything that moves differently from the fixed stars. On that July night in Chile, the system flagged a faint moving point of light. Initial checks confirmed it wasn't a known asteroid or comet. Then the orbital data came in. This object was traveling on a hyperbolic trajectory, meaning it was not bound to the Sun and would never return once it left. Its inbound direction was traced back to the constellation Sagittarius, close to the Milky Way's galactic center. That's one of the most crowded, dusty, and noisy regions of the sky, making it extremely difficult to detect faint objects there, which might explain why 3I/ATLAS went unnoticed until it was already relatively close to us. When astronomers calculated its speed, they were stunned. 3I/ATLAS is moving at about 60 kilometers per second, far faster than most solar system objects, and well above the escape velocity needed to break free from the Sun's gravity. But speed alone wasn't the only surprise. Its orbit is retrograde, meaning it's traveling in the opposite direction to the planets. That's not unusual for interstellar visitors. They can approach from any direction. But the inclination of its orbit was strikingly low, only 5 degrees off the ecliptic plane. That's like a stranger wandering into a city from far away and somehow entering along the exact main street where all the traffic is. It's rare for an interstellar object to align so closely with the plane of our solar system. Even more curious. 3. I/ATLAS is set to pass unusually close to 3 major planets, Venus, Mars, and Jupiter, in sequence. The odds of that alignment happening purely by chance are about 1 in 20,000. Now, astronomers are careful about making big claims from small probabilities. But such a path raises eyebrows, especially when the timing of its arrival would allow for potential gravitational assists, the same kind of planetary flybys we use to redirect spacecraft. It's not proof of anything artificial, but it's the kind of thing that keeps the conversation going. When a comet gets close enough to the Sun, heat causes volatile materials like water ice to sublimate, creating the glowing coma and dust tail we associate with them. But 3 I/ATLAS began showing activity much earlier than expected. At more than 4 astronomical units from the Sun, beyond Mars' orbit, telescopes detected a faint but distinct coma. Even stranger, its dust tail wasn't streaming directly away from the Sun. Instead, it was angled oddly, as if composed of heavier particles less affected by solar radiation pressure, or perhaps influenced by another unknown force. Spectroscopic observations from NASA's Infrared Telescope Facility and the Gemini South Observatory revealed a familiar mix of cometary ingredients: water ice, organic molecules, carbon-rich compounds, and silicates. But the age of these materials makes them special. Analysis suggests they have remained unchanged since the object's formation, over 7 billion years ago. That means they predate both the Earth and the Sun. The data points to an origin in the thick disk of the Milky Way, an ancient population of stars and primordial debris far removed from the stellar nurseries where most comets in our solar system were born. Early estimates suggested 31/ATLAS might be about 1 kilometer across, similar to Borisov. But high-resolution photometry now puts its nucleus between 4 and 11 kilometers wide, making it the largest interstellar object ever observed. That size, combined with its speed and pristine composition, makes it an incredibly valuable scientific target, a preserved relic of the galaxy's distant past, passing right through our neighborhood. Despite global attention from telescopes, there's a frustrating catch. 3 I/ATLAS will reach its closest approach to the Sun and its most active phase, while it's directly behind the Sun from Earth's perspective. That means it will be hidden from all ground-based observation at the most scientifically interesting moment. There is, however, a slim hope. 2 spacecraft, ESA's JUICE on its way to Jupiter and NASA's Psyche en route to the asteroid belt, will be in positions that might allow them to observe the object from space. But taking advantage of that window would require rapid mission adjustments. When 3 I/ATLAS was confirmed as an interstellar visitor, it joined a very exclusive club. In the entire history of astronomy, we've only ever confirmed 3 objects from outside our solar system, and all 3 have been detected in just the last 8 years. That's a curious pattern. Before 2017, the expectation was that such detections would be vanishingly rare, maybe once in 1,000 lifetimes. So why are we suddenly seeing them in rapid succession? There are 3 main possibilities. 1. We're just getting better at finding them. Our sky surveys are more sensitive now than ever before, and AI-assisted scanning helps catch faint objects that would once have gone unnoticed. 2. They've always been here, and we simply weren't looking in the right way. Interstellar objects are small, dark, and fast. Without constant wide-field coverage, most would slip by undetected. 3. Something has changed out there. The density of interstellar debris in our region of the galaxy might be increasing, perhaps because of gravitational interactions between stars, or a shift in our position within the Milky Way's spiral arm. And then, there's the controversial fourth possibility. They aren't all natural. Few figures in astronomy have stirred as much debate in recent years as Harvard astrophysicist Avi Loeb. Loeb became a household name, at least in science circles, after suggesting that Oumuamua might have been a piece of alien technology. With 3I/ATLAS, Loeb sees a few red flags. The shallow inclination. Only 5 degrees off the solar system's plane is unusually aligned for something arriving randomly from deep space. The planetary flybys. Passing Venus, Mars, and Jupiter in sequence has a statistical improbability that begs for explanation. Early activity. The coma appeared much farther from the Sun than is typical, and the tail behaves in a non-standard way. Loeb has even suggested that 3I/ATLAS might be worth an interception mission, sending a probe to study it up close before it disappears forever. While most of the scientific community remains cautious, his point is simple. If you ignore possibilities, you close the door on potential discoveries. For every unusual aspect of 3I/ATLAS, there's at least one plausible natural explanation. The shallow inclination? That could be a coincidence, or the result of gravitational interactions with unseen bodies on its journey here. The planetary flybys? Pure chance. Can still produce rare alignments, and the solar system is vast enough to accommodate improbable paths. The early activity and strange tail? Different dust particle sizes or compositions could explain it, especially for body that has never been warmed by the sun before. From this perspective, 3I/ATLAS is simply a large, ancient comet, a relic from another star system, behaving in ways that only seem unusual because our sample size of interstellar comets is so small. Even among scientists who reject the alien probe label, there's fascination with the idea of 3I/ATLAS as an ancient messenger, not in the science fiction sense, but as a literal courier of chemical history. Its water ice and organics have survived for over 7 billion years, untouched by the harsh radiation of close stellar passes. By studying it, we can sample the building blocks of worlds that formed before our own sun existed. If those organics resemble prebiotic compounds found in early Earth chemistry, it could lend weight to the panspermia hypothesis, the idea that life's raw ingredients may be spread between star systems by comets and asteroids. The biggest challenge in studying an object like 3I/ATLAS is time. From discovery to departure, we have only months to gather as much data as possible. Ground-based telescopes will track it until October 2025, when it slips behind the Sun. Spacecraft like JUICE and Psyche could fill the observational gap, but redirecting their instruments requires rapid planning and international coordination. If we miss the chance, it will join Oumuamua and Borisov in the category of mysteries we'll never fully solve. Let's say we wanted to intercept 3I/ATLAS. Could we? In theory, yes, but it's a massive engineering challenge. The object is moving at 60 kilometers per second on a one-way path out of the solar system. To match that trajectory, we'd need either a launch vehicle far more powerful than anything currently available, or a mission already in space with enough fuel and flexibility to change course. NASA's DART mission proved we can hit a small target in space, but that was within our own solar system, at far lower speeds. For something like 3I/ATLAS, we'd need nuclear or solar thermal propulsion, or perhaps a laser sail, technologies that exist mostly on paper today. If an interception mission were greenlit immediately, it would still have only a small launch window before the object's trajectory carried it out of reach. Every week we wait makes it exponentially harder. This is one reason Loeb and others argue for a ready-to-launch rapid response mission, a spacecraft parked in a holding orbit, fueled and waiting for the next interstellar visitor. When one is detected, the craft could be dispatched within days. Such a system could turn rare surprises into planned opportunities. Studying 3I/ATLAS up close could answer key questions. How common are certain organic compounds in other star systems? What differences exist between interstellar comets and those born in our own Oort cloud? Do the physical properties of 3I/ATLAS point to a unique formation history, or even an artificial origin? Even if we find nothing alien about it, the science payoff would be enormous. Every interstellar object is a piece of the galaxy's jigsaw puzzle, carrying information about places we may never visit. Perhaps the most important takeaway from 3I/ATLAS isn't about this one object at all, but about the trend it represents. If 3 interstellar objects have appeared in just 8 years, it means they're far more common than we once believed. That has implications for planetary defense, for astrobiology, and for our understanding of galactic dynamics. It also means that the next one could be even stranger. One of the most frustrating realities for astronomers is that 3I/ATLAS will vanish from our view long before we can fully understand it. By late October 2025, it will pass behind the Sun from Earth's perspective, a period known as solar conjunction. During conjunction, our ground-based telescopes are effectively blind to it. The Sun's glare makes observations impossible, and even the most advanced space observatories have to tread carefully to avoid damaging their sensors. When it reappears months later, it will already be heading out of the inner solar system, dimmer, less active, and much harder to study. The window of opportunity will be gone. That's why missions like JUICE and Psyche could be game-changers, if their teams choose to act now. Ironically, the period when 3I/ATLAS is invisible to us will likely be the most interesting part of its journey. This is when it will be closest to the Sun, absorbing intense heat and releasing the maximum amount of gas and dust. If something unusual happens, say a sudden change in trajectory or an unexpected drop in activity, we might never see it. And that leaves room for speculation. Some scientists even joke that if an alien probe wanted to adjust its course without us noticing, doing it during solar conjunction would be the perfect time. Even without direct visuals, we can sometimes learn from what an object leaves behind. The coma and tail of 3I/ATLAS will disperse particles into space, and those particles might eventually cross Earth's orbital path. If they do, we could detect them as meteor showers years from now. Such meteor streams could give us physical samples of interstellar material without the need for a spacecraft intercept. Every tiny grain would be a message from another star system, and possibly older than our own Sun. If we could trace 3I/ATLAS's path far enough backward, we might be able to pinpoint its origin. That's far from easy. The galaxy is in constant motion. Stars orbit the galactic center, spiral arms shift, and gravitational nudges from massive objects can alter a small body's course over millions of years. But there's a slim chance. If the trajectory intersects with a known stellar system, especially one with planets in the habitable zone, it could open a whole new avenue of research. Here's where the more speculative minds go further. If 3I/ATLAS were artificial, could it be a messenger? Not in the science fiction sense of sending greetings, but as a passive object carrying information, perhaps etched into its surface, encoded in its spin, or hidden in its composition. The idea isn't entirely without precedent. Humans have already launched interstellar probes like Voyager 1 and 2, each carrying a golden record with information about our species. If we've done it, why couldn't someone else? The truth is, we've never had the right tools ready at the right time. Oumuamua passed before we could even react. Borisov gave us more data, but still no close-ups. 3I/ATLAS is the biggest opportunity yet, and we're still scrambling to prepare. That points to a larger issue. Our planetary science priorities are often reactive, not proactive. If we want to understand interstellar visitors, we need a standing fleet of interceptors, spacecraft ready to launch at a moment's notice, waiting for the next alert. From the moment of its discovery, 3I/ATLAS has been racing toward its closest approach to the Sun, and every day brings it closer to the point where it will fade from our view forever. By mid-2026, it will be well beyond Jupiter's orbit, heading for the cold outskirts of the solar system, and eventually back into interstellar space. Once it's gone, it's gone. No second chances. No way to catch up. Whether 3I/ATLAS is a natural comet or something more unusual, its visit is teaching us valuable lessons. Interstellar objects are more common than we thought. Our detection systems are improving, but still too slow. We need rapid response missions, ready to go. Most importantly, it's reminding us that the solar system is not an isolated bubble. We are part of a galaxy filled with movement, collisions, and exchanges of matter. And sometimes, pieces of those distant places come to us. The arrival of 3I at Atlas isn't an isolated event. First came Oumuamua in 2017, a long cigar-shaped object with no comet-like tail, but an unexplained acceleration. Then Borisov in 2019, a textbook comet, but with a chemistry we'd never seen before. And now, 3I/ATLAS in 2025, larger, slower, brighter, and far more suspicious in its trajectory. 3 visitors in less than a decade. That's not just a coincidence. It's a pattern. Some astrophysicists believe this might be a sign that our corner of the galaxy is becoming busier, that gravitational tides, shifting star positions, or unknown galactic events are funneling more debris toward our solar system. But others think the explanation might be more targeted, not random, not natural, deliberate. Enter Avi Loeb, Harvard astrophysicist and one of the most outspoken scientists in the world. Loeb has been warning for years that we need to be open to the possibility of extraterrestrial technology visiting our solar system. He argued that Oumuamua's acceleration could have been the result of light-sail propulsion. He suggested that some interstellar meteors could be fragments of alien craft. And now, he's openly saying that 3I/ATLAS could be artificial. His reasoning? The incredibly low inclination of its orbit, the near-perfect alignment with the inner planets, and the fact that it will pass close to multiple worlds in sequence, something nature doesn't usually do by accident. Mainstream astronomers push back saying there's no hard evidence for this. But the simple fact that a scientist of Loeb's stature is willing to raise the possibility keeps the public and the media watching closely. If 3I/ATLAS is ever going to reveal its true nature, it will happen in the next few months. During its perihelion, the closest point to the Sun, its surface will undergo massive changes. Ice will sublimate, gases will jet outward, and its structure could shift in unexpected ways. High-resolution imaging could detect shape changes, spin variations, or unnatural geometric patterns. Spectroscopy could reveal exotic materials, things we don't expect to find in natural comets. But to do that, we have to catch it in the act, and that means taking risks with spacecraft maneuvers and telescope time. NASA's Psyche spacecraft, currently on its way to study a metallic asteroid, will pass within 0.4 astronomical units of 3I/Atlas. ESA's JUICE mission will be even closer, just 0.3 astronomical units at the right moment. If either spacecraft diverts slightly, their cameras could capture images of the object at resolutions far beyond anything Earth-based telescopes could achieve. Imagine the shot: a jagged, dark body with sunlight glinting off ancient ice, framed against the black void. Or worse, and far more intriguing, something too regular, too smooth, too engineered to be natural. Here's the uncomfortable truth. If we don't make the effort to observe 3I/ATLAS up close, we might lose our best chance in decades to study an interstellar visitor in detail. We can argue all day about whether it's a comet, a fragment of a shattered world, or a probe. But without close-range data, it will always remain a question mark, filed away as unknown in the history of astronomy. In the future, when humanity has a permanent network of interceptors ready to launch, we might regret letting this one slip away. The composition of 3I/ATLAS is like a time capsule from the early galaxy. The ice in its core predates Earth. The dust embedded within it was forged in the atmospheres of dying stars billions of years before our planet even formed. To study it is to look back in time, not hundreds of years, not millions, but billions. Every molecule tells a story of stellar births, of cataclysmic explosions, of the mixing of matter across light years. And right now, that story is passing through our cosmic backyard. Is it possible that 3I/ATLAS is simply a comet? Absolutely. But is it possible, however unlikely, that it's more than that? That's the question that keeps scientists awake at night. Because if it is something more, it would be the most important discovery in human history. It would mean we are not alone. It would mean someone, or something, knows about our solar system and has been here before. As October approaches, the astronomy community is holding its breath. We're watching every change in brightness, every fluctuation in trajectory, every odd behavior in its coma. We're waiting for the moment when the data either confirms what most expect, a strange but natural comet, or cracks open a mystery that will define the century. In just a few months, 3I/ATLAS will begin to fade from our view. By 2026, it will be a dim speck in the outer solar system, heading back to the stars. When it's gone, we will be left with terabytes of images, spectra, and orbital data. But also with one haunting unanswered question: what was it really? And maybe, just maybe, the next visitor will give us the answer.